Hello, this is question, what is it, 7 in the 2010 maths. So in a game of cat and mouse, cat starts at position 0, and mouse starts at position M, and the mouse's hole is at position H. Here M and H are integers with 0 less than M less than H. Right, so the mouse is always between the cat and the hole. By way of an example, the starting position is shown below. M is 7 and H is 12. So we've got the cat at 0. And then 1, 2, 3, 4, 5, 6, 7 to the mouse, 8, 9, 10, 11, 12 to the hole. Wonderful. With each turn of the game, one of the mouse or cat, but not both, advances one position towards the hole on the condition that the cat is always strictly behind the mouse and never catches it. That's pretty rubbish, cat. The game ends when the mouse reaches the safety of its hole. Safety of the hole. The cat can't catch the thing. Anyway, I suppose it's safe from other things apart from this useless cat. At position H, right, so we just keep on going until the mouse reaches the hole, but I'd say the mouse is perfectly safe outside of the hole if the cat can't catch it. This question is about calculating the number G, H, function of H and M, of different sequences of moves that make a game of cat and mouse. Right, okay, let C denote a move of a cat, M denote a move of a mouse. G31 equals 2, G31, so 3, 1, what does that even mean? The number of sequences for an H being 3 and a mouse being 1, so it would be cat, mouse, gap, hole. How many ways can we finish the game? So the mouse has to move first, so we have to go to cat, something, mouse, hole. So that's, you have to start with a mouse. Then we could do mouse again, or we could do the cat and then move the mouse. Right, so that's those two sequences. Right. Also, CCM is not a valid game when H is 4 and M is 2, as the mouse would be caught on the 4th turn. Yes, it would. So because the cat starts at 0, then it goes to 1, then the mouse goes to 3. 2 cat moves would mean they're both on 3. Write down the 5 valid games when H is 4 and M is 2. So H is 4, M is 2. That means we've got cat, gap, mouse, gap, hole. So 5 valid games. So we could just go mouse, mouse. We could go mouse, cat, mouse, mouse, cat, cat, mouse. We could start with a cat and then go mouse, mouse, or we could go cat, mouse, cat, mouse. Right, that was fine. Part 2, explain why GH minus 1 equals H minus 1 for H is greater than or equal to 2. What's the H is greater than or equal to 2? Got to do with anything? Well, otherwise M would be not greater than 0. Right, so that's not really going to factor much in our thinking, I don't think, on that. Right, so if we're doing H minus 1, that means we've got cat, the hole is at H, the mouse is 1 closer. So the mouse is sat next to the hole, and we've got some number of spots in between. So we've got possible sequences. We can do up to, how many? We can do up to H minus 2 cat moves, C moves. And we must end with an M. Well, all sequences have to end with an M. So that means we've got, therefore, total sequences are going to be, you've got H minus 2 possible C's you can put at the start, plus 1, which is H minus 1. Okay, this is good. Explain why GH2 equals GH1 for H is greater than or equal to 3. H is greater than or equal to 3. Oh, that's just showing that H is more than M, because M has to be 2 or 1. Right, so explain why. So what are these then? So we've now got cat in his usual spot. We got the mouse is either right next to the cat, and then we're going up to the hole, or we've got a gap of 1 to the mouse, and then we're going up to the hole. So how many dots have we got in these then? So this would then be, well, the hole's in the same place. So this must be, we're 2 along, that's at H. So we've got 2, oh, that's at position H though. And this is 2 along. So we're going to have H minus 2 minus 1 whole. So that'll be H minus 3 like spots between M and H. M and H, okay. And in this one, we're going to have H minus 2 spots between M and H. So why are these the same? Well, the top one, we have to start with an M, and that's going to put us in exactly the same position, isn't it? Yeah. So, yeah, because you don't have any choice. You can't move the cat on the top one. So the top option, so this one, so how are we going to write this? So for G, H, well, just for H1. For H1, first move must be M, which means we're then in H2, which is the sequence for the other one, but we haven't completed any sequences. Yeah, but no sequences complete of the first move. Or can we have them right next to each other? Oh no, because H has to be at least 3 away. There has to be at least one gap in there. So, but no sequence complete after M, because H is greater than or equal to 3. Right, okay. Therefore, GH2 equals GH1. Yeah, okay, it's getting progressively more complicated. All right, let's go on to a blank sheet then for the next bit. By considering the possible first moves of a game, explain why GHM equals GHM plus 1 plus GH minus 1 M minus 1. Oh my word. For 1 is greater than, so M can't start, the mouse can't start next to the cat, is what we're saying here, and it can't start next to the hole. Right, so we've got a setup then of cat, some dots, mouse, some dots, hole. So we can start with either a cat or a mouse. So starting move can be C or M, without completing the sequence as well. That's the other thing. Without completing sequence, because of that inequality. Because 1 less than M less than H minus 1. Right, so what does that mean? Considering the possible first moves of the game. So let's go then. If M first. So we've moved to M. We haven't completed a sequence at all. That means we've gone from HM to HM plus 1 with no completed sequence. No complete sequence. So that's good. I mean, this is pretty much what we did in the last question, and that's given us that bit. So I'm assuming if we do cat first, we're going to get the other bit. If C first, then we're going from HM to, right, so if C moves first, yeah, we're dropping these back one place is essentially the same. Then we're going to H minus 1, M minus 1, because C is always at 0. Yeah, so this is equivalent to moving the mouse and the hole back 1, just to make that clear. Right, so that's okay. And again, that would have no completed sequence. So with no completed sequence, therefore, we've got exactly what they want. The GHM is equal to GHM plus 1 plus GH h minus 1, oops, m minus 1. Okay, that was fine. So we've done all of them. Below is a table, well, off to the right is the table now, with certain values of GHM filled in. Complete the remainder of the table and verify that G61, so our bottom right corner, is 42. Right, so they've given us the 1, 2, 3, 4, 5. We worked out something earlier on, didn't we? Oh, we got 3, 1. There's 2, so we can put that in. And we did another one where there were 5 permutations. Oh, yeah, in part I. So H is 4, M is 2, so that is 5. So we've got a couple of numbers. So how's that going to work out with this then? So if we were doing, oh, we can't use it for the bottom row because M has to be greater than 1. So what if we were going to do it for M is 2 and H is 5? So G 5 2 is going to be equal to G 5 3 plus G 4 1. And we don't have any of those. So that's rubbish. So how does that work then? So G 5 2, so that one is the sum of the one above it and the one diagonally down and left. So that is that. Do we have any more that match up to this? So that one, we should be able to do 5 3 then, because G 5 3, so let's do that one, is going to be equal to G 5 4, which we do have, plus G 4 2. Excellent. So that is going to be 9 in there. Okay, so that's good, which means we can do this one up here would be 14. Right, but we don't have, we don't have the other ones, because this one we've got stuff missing. How are we going to work out these others then? So what are, we done the bottom row. We did the bottom row in this one, in part 2. Yeah, because that is with a mouse one away from the hole. Is it? Yes. No, it's not. That's with M, that's with the M one away from the cat. So, oh my word. So no, that doesn't work. Oh, I thought it was going to be, but yeah, we do have if they're one away from the hole. So if the mouse is one away from the hole, it's one less than, have I done all of those? Yeah, we've done those. So that doesn't help either. How am I going to get these other numbers then? Or do I just have to work them out? If you've got mouse going, H is 4, so we've got C mouse dot H. So we have to do 3 mice in there, but you've got, so you can do mouse, 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 and we can intersperse various cats into this. Mouse, mouse, cat, mouse, 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 cat. This is going to be too many. There must be another way. Is there something else that I've done in this? But H is greater than 3, which is all of these. G of H2 equals G of H1. Right, so these are just dropping down then. So that would be a 5. Right, that's fine. Which means we can now fill in this one. Right, yeah, it had to be somewhere in what we'd already done. It's using that one. It's using the third one. So they've already provided us with that one, I think. I used that to put a number in. This third one is just saying that the bottom row is the same as the row above it. So that would have to be another 14. We can add those two 14s for a 28. We can then add the 28 and the 14 to get a 42 and then drop the 42 down because the bottom row is the same as the row above it, which is the 42. Right, okay, that was a challenging finish. And that's another great question. This 2010 paper has just been brilliant. I think all the long questions have been good. A lot of the short questions are pretty good as well. But yeah, they were on fire setting these questions for this year. But yeah, I like that question. It's another one of those ones, same old thing. I know I say it every time. Go through the permutations, be methodical, and then write out what you're doing in these permutations with this if-then structure. So if this, then that, and then that will prove something. So yeah, just keep taking that approach. You can see why this is for the computer science people. This is like you're pseudo coding something in a lot of ways. You're writing the flow control of your program in your answer as your explanation for why this all works. So yeah, just write it out that way and everything just drops into place.